I have quite a few PCs, servers, and other network appliances throughout my house, and that works fine for me. But what if I could take everything from my NAS to my remote editing PC to even my router and run them all in one single server? Well, today I think I can, thanks to this. Can is different from should though, because this might not be the absolute best idea. Now, before we get too deep into things, I just want to take a second to thank the sponsor of today's video, Squarespace. Now, you guys have heard me talk about how easy Squarespace makes it to set up a website, but there are so many features you might not be aware of, like email campaigns, for example. Being able to run email campaigns directly from within Squarespace makes things super easy, but it can also save you money from paying for a different service. And because everything's integrated into Squarespace, you can set up cool automations to send an email after a customer makes a purchase, for example. There are tons of other features you can go check out using a free trial, and then when you're ready to get started, you can go to squarespace.com/hardwarehaven and use code hardwarehaven to get 10% off your first purchase of a website or domain. So what are you waiting for? Get your website up and running with Squarespace. This is the AMD Ryzen 9 3950X, a 16-core 32-thread CPU based on the 7nm Zen 2 architecture. It has a base clock of 3.5 GHz and can boost up to 4.7 GHz under certain conditions. The 3950X originally released at $750, but is now over 3 years old and can be found used for around the $300 mark or so. I was super lucky and managed to grab mine locally for only $220. Now, really quick, if you watch this channel normally, you might be wondering why I'm covering this, because I typically don't cover more high-end stuff. Well, the main reason is because I didn't buy this to make a ridiculous server. I actually got this for video editing. But before swapping things over to my main desktop, I thought it would be fun to throw some VMs and such at this beast of a CPU and see what all it could do. But it can't do anything without a motherboard, so that's where this Gigabyte B550 Vision D-P comes in, which I also bought specifically for my editing PC. It's only B550, but I think it should be totally fine for what I'm doing, as I'm not going to be overclocking or anything. This motherboard honestly has some really slick features, starting with integrated Thunderbolt 3 ports, which, due to my audio setup, is a requirement. It also has dual 2.5 gigabit NICs, and interestingly, one has an Intel controller, while the other has a Realtek controller, which is almost a nice little bit of redundancy in case there's ever a lack of software support or driver issues. There are 3 PCIe slots, 2 of which support PCIe 4.0 and are integrated into the CPU. The third is only a 3.0 by 4 slot, and it's integrated into the chipset, which might cause some issues. More on that later. I clearly bought this for my editing needs, and I don't think it will necessarily be the best value for server workloads, but it actually does support ECC memory, which is pretty cool either for server or workstation use. I'm not going to be using ECC memory today though, as I actually had these 4 16GB sticks of Crucial DDR4 2400 memory, which should give us quite a bit of options for virtual machines and such. I'm going to use the Deepcool AK620 to keep the Ryzen 9 cool, and a spare EVGA 650W power supply, which should hopefully be enough to power everything. We'll see. I'm not using a case for this because, well, obviously it's immediately going to get broken down and repurposed after this video. Now, I have even more hardware to add to the system, but I think it'll make more sense to talk about that after the software. Now, my main goal in this project is to virtualize as much of my home lab and network as possible, so I'm going to install Proxmox as a hypervisor, and then run containers and VMs to replace various servers and appliances, starting with my pfSense router. If you haven't seen that video, you can check it out here, but essentially it's also running Proxmox with a pfSense VM and LXC containers for Pi-hole and WireGuard. It shouldn't be hard to set up pfSense in a virtual machine, but I will need network interfaces. I could use the 2.5 gigabit NICs on the motherboard using a bridge and or VLANs, but I like running dedicated interfaces when possible. So I'm going to use this quad 2.5 gigabit PCIe card and use PCIe pass-through to pass it through to the virtual machine. Now, this card does use Realtek controllers, which isn't the best for pfSense, but you can install the correct drivers and get it working decently well. For Pi-hole and WireGuard, I'm just going to set up LXC containers just like I did in my virtualized router video. And yes, I know pfSense has the ability to run these things or similar things natively, but I just like the idea of having things isolated for flexibility. I'm also going to add a Windows VM to act as my remote editing PC, which you can also see in a video here. The goal here is to have a Windows PC I can remote into using Parsec to edit videos and maybe even play some games while on the go. I was originally thinking about using this Tesla P4, which as you can see has a very sophisticated cooling apparatus on it, but it was going to be a bit tricky to get virtual displays working properly since this doesn't actually have any display outputs. So I'll just save this guy for a future video. Instead though, I'm going to toss in a GTX 1650 Super, which should help a lot with Adobe Premiere and obviously games. Since I already have a GPU for this virtual machine, I'm also just going to run Jellyfin in Windows so that it can take advantage of the GPU's hardware transcoding. Another device that I have running 24/7 is my NAS, as well as my other NAS, and my other NAS. I could run 3 virtual machines, but that would be a bit dumb when they're all on the same physical machine. I mean, my Asustor NAS, which is back there, is just a local backup for my main NAS. And the whole idea is to have completely separate machines, so yeah. And my Synology is really just for running my security cameras. So I'll just be setting up one virtual machine for a NAS, but this is where, when testing, I ran into a bit of an issue. See, I had planned on running either a SATA PCIe card or HBA, and then pass that through to a virtual machine running TrueNAS. But because the bottom PCIe slot runs on the chipset, I think, whatever PCI device is plugged into it is stuck in the same IOMMU group as everything else on the chipset, so I can't really pass it through to a virtual machine. To not drag this video out way too much, I think I'm just going to attach these two 10TB drives via SATA, set up a ZFS mirror within Proxmox, and then create a virtual disk to pass through to a VM running OpenMediaVault. Now, OpenMediaVault should make setting up network shares pretty simple and is even a good place to run Docker containers and such. But since OpenMediaVault is just running Debian, I'm going to also install Casa OS on top of it, which I actually tried this out in my last video and you can check that out. So I'll end up having a single virtual machine for running my NAS with OpenMediaVault, as well as running Docker containers with a nice web UI with Casa OS. Even after making sure I have enough RAM available to Proxmox for ZFS, I should still have a good amount of resources available, even after all of these virtual machines. So I might even mess around a bit with setting up a dedicated VM for a Minecraft server or something else, but we'll see. I don't think I have much else to say, so let's go ahead and go put this all together. Oh, crap. Oh, there we go. Okay, so we have everything hooked up back behind the camera over here, and it's working now, at least after a few little goofs, but yeah, it's up and running. We have our 4 16GB sticks of RAM, our CPU is showing up properly, and we have down here what looks to be our SSD, which did have Proxmox installed on it because I did some testing before this video just to see if any of this was possible before wasting a lot of time. So, but yeah, we're still going to dive in and see what we can get done. So let's go ahead, and I have Ventoy plugged in as well. I'm going to go ahead and boot into that and let's get going. Oh, actually, I'm going to check a few settings here. We'll go ahead and make sure that we have, it's here, SVM mode. We're going to enable that. There is IOMMU, and we'll enable that just to make sure. And I think we're good. Okay, and we have Proxmox up and installed, and I've actually done quite a bit of work here off camera just because most of the stuff I've covered in primarily my Proxmox server guide thing that I'm sure I'm showing on screen right now. You can check that out, but basically what I've done, we'll hop over here. We can see we have our 32 thread server here. We have our CPU, we have our RAM, we have all three of our drives, which I haven't done anything with the 10 terabyte drives yet. And then in our local storage, I went ahead and uploaded 3 ISOs. So we have our Windows 10 ISO, we have our Open Media Vault ISO, and our pfSense ISO, which pfSense is what we're going to start with. And I actually already did. You can see I have this VM here, VM100. I should rename this really quick. Okay, so now it's called pfSense, but you can see we have just C BIOS here, and then Q35, that way we can run PCIe. And then I have my 4 PCIe NICs here. I also set up just a virtual NIC here just to make sure that pfSense could boot up and I could download the drivers for these. I downloaded the Realtek driver in the same way I did in my Ultimate router video. So yeah, if we hop into pfSense here, we should be able to start it up, and we should have 4 NICs that aren't set up but have Realtek drivers available. So let's go ahead and check that out. Okay, so we're in pfSense here, and we can see we have this WAN interface configured on EM0, which is just a virtualized Intel NIC. But if I hit 1 to assign interfaces, we can see we have these 4 Realtek 2.5 gigabit NICs available. So I'm going to go ahead and configure these to be WAN and LAN port. So the WAN port is going to come just from my local connection because this will be a router behind my main router. And then I'm going to run a LAN port to a small 5-port switch over here that I'll go ahead and plug my desktop into and probably get our whole Proxmox server plugged into as well. That way we can sort of run this entire thing using our router, which could be a little scary, but yeah, that's probably not a good idea. So give me just a minute and I'll be done with all that. Okay, so I skipped a lot, but once again, if you're interested in any of what I didn't do anything that's not in my Ultimate router video that you can check out. But yeah, we have I kind of chickened out just because it's already getting pretty late. I'm not going to run everything off of the router. I'm just going to get it up and running. But right now I'm remoted into this router on my desktop using 192.168.100.1. So I'm actually running off of this interface, and just to really test things out, I'll disable my current network connection. And I should still be able to go to something like this. Yeah, so it's actually working. We're getting DNS, we're getting web access through our virtualized router. So cool. I'm going to fix that before I forget. But yeah, we have this one interface here working. We do have the other 4 interfaces working as well. I just haven't actually set them up because I don't really have a need to at the moment. So I think now we're going to move on to setting up Windows. So let's get started there.
One day later.
Okay, so it's been basically 24 hours since I was recording because I ran into some issues. I haven't had too many issues in the past with GPU pass-through in Windows on Proxmox. I've done a couple videos doing that, but for some reason, this thing kicked my butt. I really still, unfortunately, don't know why I can't get it to work. I stayed up till a little after midnight last night trying to work on it, and then I've been working on it all evening today, and I still just can't get it, and I want to get this video done. So sadly, we won't have GPU pass through to our Windows VM, but I kind of just worked around it and got something because I wanted to get this video done. I wanted to play around with it a little bit, but also not spend the next entire week trying to get it working. So I apologize. I wish this video was better, but this is what it is, you know? This one's for all those people, I guess, that think I chop out all of the hard stuff and just make it look easy, because things go wrong all the time around here. So just a brief explanation of what wasn't working. Every time I tried to get PCIe pass-through working with my GTX 1650, I would always get a weird ROM bar errors, and then basically what I think is that the host operating system wasn't letting go of the GPU. And I followed the guides I've used in the past. I've followed a ton of other forum posts and still just couldn't get it to work. I actually even tossed a, hold on. Since I wasn't using the third PCIe slot, I actually tossed this R7 240 into the third slot and then assigned that in the BIOS to be used as the primary GPU. And still, I couldn't get it to work. I tried so many settings, I tried so many things, and eventually it just wasn't worth it for the sake of this video. But I did get a lot of stuff installed, and so I'm going to hop in, show you what I got, and let's mess around with it. Oh, I should mention before we start doing too much, we're idling at around 118 watts or so running what we're running. So let's check it out. Okay, so here in the pfSense dashboard, you can see we have this Tailscale. Instead of running WireGuard, I actually decided to run Tailscale. I thought that would be fun. So this is just a Debian Linux LXC container that I set up to use WireGuard in the same way that I did in my CasaOS tutorial, I believe, at the very end of that. So it's pretty simple, just Debian. And then I did have to set up some tunneling stuff. It's the same setup that I basically used when I set up WireGuard in an LXC container in my Ultimate Router video. And same thing with Pi-hole, exact same setup here as I did in my Ultimate Router video. So those are both running. I have my pfSense router that is 2 gigabytes of RAM, 4 cores, and then I have my quad 2.5 gigabit NIC pass through, and it's working. And so far, no issues. So Windows. I originally was going to run this with 32 gigabytes of RAM and 24 cores, or 24 threads essentially. But since I couldn't get GPU pass-through to work, I wasn't doing as much with it, so I just pushed it down to 16. I feel like we might run Cinebench here in a second and see how much power this thing draws when we really go after the CPU a bit. And so, unfortunately, that's not doing anything fun. But I do have this OpenMedia Vault and Casa virtual machine here, and that's actually taking advantage of our two 10 terabyte drives that are set up in a ZFS mirror here. If I go to 32 thread down here, ZFS, you can see we have our two 10 terabyte drives, and yeah, they're set up and working, and then those are just passed through as a virtual disk, and it's 8,000 gigabytes just because trying to get the exact amount was going to be annoying. So it works. I can actually, hop in here to the terminal. It's just OpenMedia Vault, and then I installed CasaOS on top of it in the same way that I did in my video where I've talked about installing CasaOS on top of OpenMedia Vault. No idea how stable it'll be long term, but right now it works. So yeah. And I have a network share called OpenMedia Vault, and then I have this 32 thread share, and I have some stuff in it. So that's all working thanks to OpenMedia Vault. And then I can actually go to omv.local, and instead of taking me to the OpenMedia Vault web UI, it actually takes me to the CasaOS web UI. So it's funny that it's OpenMedia Vault, but I can get to the OpenMedia Vault UI here, just as I normally would. And you can see under disks, we have our boot disk, and then we have our 8 terabyte or 7.81 TB, technically ZFS mirror here. And then I have a file system set up on that, and then a shared folder and SMB, and you know the whole gist of it. So that's working. And then in CasaOS, sadly, I don't have a GPU really to get passed through. I was almost considering trying to get rid of the GPU and use something like the Tesla B4 to still get some hardware transcoding, but this video was taking a long time, and I needed to get it done. So I figured we have 16 cores and 32 threads. We might as well just do, software transcoding. So I have Jellyfin set up here. And as per usual, I could just play Knives Out. And this is actually on my SMB share that OpenMedia Vault is taking care of for me. It is playing just fine. And if I go to playback info, we can see we're getting a transcoding frame rate of 104 frames per second, which is plenty. But if I go back to CasaOS, you see our CPU is definitely doing some work right now. And actually, we're pulling about 215 watts off the wall, sitting at idle everywhere else and running Jellyfin. So not the most power efficient. To be fair, we're also running a GTX 1650 that's doing nothing. So, oh well. I also have a Minecraft server that, to be fair, yes, there is a Minecraft server running in this OpenMedia Vault container with 16 gigs of RAM. Oh yeah, I gave the whole thing 32 gigs and 24 cores, I think, 16 cores. How many? Yeah, 24 cores and 32 gigs of RAM, because I figured this is going to be handling most of our stuff. But yeah, so we're sitting at a solid 215 watts. Let's see what happens if we just run some Cinebench, right? That should be fun. All right, so I have Cinebench R23 pulled up here. Let's go ahead and hit CPU multi-core and see what we have. All right, so now we're pulling 285 watts from the wall. Let's go ahead and hop back into Jellyfin and see if we can't transcode a movie while we're running Cinebench with 24 threads. Okay, so we're transcoding at 42 frames per second, which is plenty for this. We need at least 24, I think. So that's doing fine. And while we're doing all of that, let's go ahead and jump into Minecraft. Why not? We got these 32 threads for a reason, right? Okay, well, I guess it's nighttime. That's not good. Is the sun coming up or coming down? I don't know, but it seems to be working fine. Back in Casa OS, we're sitting at 42% CPU and 67% RAM. So I don't imagine we're having too many issues just running this server right now. Seems to be running totally fine. And we're still sitting at about 290 watts, so not too terrible. Yeah, not too terrible. 290 watts from the wall is not too bad playing Minecraft. Oh, geez. Is this a peaceful server? Nope, it's not. Hello. Okay, so we're not done. We still have about 5 minutes left on the run, but just off of our first few renders here, it's putting us between a original AMD Ryzen Threadripper 1950X. Yeah, Threadripper 1950X, which was a 16-core 32-thread processor, and an Intel W3265M. So for being on a virtual machine with not even the full amount of threads while also software transcoding video and running a Minecraft server, you know, that's not too bad. We're running a router, VPN server, DNS server, Windows machine with sadly no GPU pass-through, a NAS, Minecraft server, a Jellyfin server that can't take advantage of hardware transcoding. So not the best. 290 watts is not the best to be running all the time, but I don't think you'd be running Cinebench all the time. So I'm curious to see actually what this looks like when we're not running Cinebench. Just playing Minecraft. Okay, so we're done, and we scored pretty well. We scored a 17,721, which is, you know, about twice as good as the Ryzen 7 1700X, which I used to have. Yeah, it's pretty old these days, I guess, but better than the original Threadripper 1500X, which is not too bad for being in a VM while also doing some other stuff. So now we are not video transcoding. We're not running Cinebench, just running our Minecraft server and the other stuff in the background. And we're only pulling about 119 watts or so. Not great, but it's not terrible for the amount of power this system has. So would I recommend something like this? Probably not. I mean, I guess when you think about it, running, you know, my router, my NAS down here, which I think draws around 45 watts at idle the last time I checked. My remote editing PC, which this isn't quite taking the job of right now, but, you know, if I was rendering, you know, Cinebench may be kind of similar in terms of power draw. When you kind of take into account all the things it's doing, it's not that bad in terms of, you know, efficiency. So maybe, but I also had tons of issues trying to get one virtual machine working, and in the process of trying to get that VM working, I had to keep taking all the other ones offline. So there is something to be said about having physically separate machines for different things. I mean, that's the whole reason that with my router, for example, the only things running on that are router and network specific services. So my router, Pi-hole, and WireGuard. So I basically never touch that machine because it just keeps running in the background, and then I mess around with other stuff and break other things, but my network stays up. So yeah, I definitely don't think I would recommend getting something like this. But if you, let's like say you do just want to run a bunch of Minecraft servers and host them, then like, yeah, this could be decent. It might be better to get a small cluster so you have some high availability or something rather than just one machine. But it was fun. It was fun seeing what this thing could do, and I'm excited to finally actually put it in my editing rig so I can edit videos faster and render them faster and stuff. But I think that's about it for this one. Thank you guys so much for bearing with me through the pain. Hopefully it was a fun look at something different. And let me know if you liked it. Let me know if you hated it. I'd love to hear your thoughts in the comments below. But I think that's about it for this one. So as always, thanks for watching. Stay curious, and I can't wait to see you in the next one.